All right, good morning. So last Friday, we left off with the law of cosines and how it looks like. So over here we have three different forms, and they're all essentially the same steps. It just, again, depends on what side we're looking for. But over here, these three, we're going to use if we're looking for a side. So if the example we're given, we have a side angle side, then we would use this formula to find that third side. And then, like I said last week, after we find that third side, then we can use a combination of either law of cosines or law of sines to find the rest. Usually law of cosines we only need to use once. If I'm given three sides and I need to find one of my angles, then I'm going to use one of these, also known as alternative forms. All right, and that's when we're given side, side, side. So this, again, like I said last week, this is the first time that we're seeing an example where we can find the angle of a triangle with no other given information about the angles. Okay, usually we need one or two other angles to help us figure out what's going on inside a triangle. But now with our law of cosines, we can find the measure of an angle when all we have is the sides. All right, so let us look at some examples. All right, so here, let's look at this triangle here. I'll try to keep those in frame for now while we're learning them. All right. So here we are going to solve the triangle. So if we're just looking at this, without knowing that I was specifically looking for law of cosines, and I wanted to solve the triangle, well, looking at the angles, I only have one angle, so I can't do, basic trigonometry, geometry stuff to find a missing angle. It's not enough information. So then the next thing I say, let me take a look, and maybe I can do law of sines, right? So this 9, I don't have the opposite angle there. And this 12, I don't have the opposite angle there. And this 25 degrees, I don't have the opposite side. So I can't use law of sines because we need to know at least one set of a side and an angle. All right, this would be side B over here. This would be side C over here. So I don't have any matching pairs. So normal geometry and law of sines are out the window. We can't use them. So what we are looking for, one of the first things that we can find is what is A? What is side A? Right, because again, I don't have any way to start with the angles right now. So if I'm looking for side A, then I'm going to be using this first model, this first equation for law of cosines. All right, again, they're all similar. If I was looking for B, I just pick this one, and it's the same steps with the remaining pieces. All right, so for A, well, first it's going to be A squared equals, I'm just going to write everything out so you can reference. All right, so it's a combination of addition and multiplication of my other two sides times the cosine of the angle that I'm given. All right, and that's the pattern that we have for any of them. All right, so here, if I'm looking for side B, I don't have any side B in here, but I have angle B. Here, if I'm looking for side C, no side C, but I have angle C. All right, so that's kind of the pattern I want you to start recognizing. So we're just going to plug everything in. This is going to stay a squared until the end. Right, our last step will be getting rid of that squared. And then I'm going to have 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of my angle, which is 25 degrees. Very straightforward. If you have a physical calculator, you can type this all in at once. Okay, your calculator will handle it. If you're using your phone, I would do this step by step. All right, so for the first time, I'll do it step by step. So the 9 squared gets me 81. The 12 squared gets me 144. This, you know, I'm not expecting you to remember that, so I'm just going to type in 2 times 9 times 12 times the cosine, times the cosine of 25. Let me make sure I'm in degree mode. Yep. So here, you're going to get a decimal for this part, okay? Which means more than likely you'll be getting a decimal for that remaining side. So just be aware that, you know, even if these two are whole numbers, that third side will more than likely have some decimal part because you're dealing with the cosine of 25. So when I calculate this whole thing, 9 times 12 times 2 times the cosine of 25, I get about 195.76. Now again, we want to be as accurate as possible. So the more decimal points you have, the more accurate you're going to be. What I'm going to do is I'm going to use the entry that I have in here. And I'm going to use that whole thing. So remember, if you have a calculator, if you press the second key, it's blurry because of the thing, I think. But if you press that second key, which is that blue one up there, or on the other calculator, you know, I think, oh, it's also blue. And then you press the minus key, it takes your previous answer and it plugs it in. I'm going to do 81 plus 144 minus that answer. And I'm going to get a squared is 29.24. All right, but be careful. We're not done. All right, we still have that squared. And even if I was done and I've decided, okay, let me write this in here. This is 29.24. Well, that doesn't make any sense because this triangle may not be drawn to scale, which means its angles might be a little weird. But 25 degrees is more than likely going to be the smallest angle, right? It looks like the smallest angle. And 29.24 is much larger than what we have there. So more than likely, that's not going to be our solution, right? So we have to take the square root of both sides. Now, because we are dealing with geometric figures and geometric concepts, I'm going to contradict myself in what I said earlier this year, and I'm not going to put a plus or minus in front of the square root, because it wouldn't make sense to have a negative measure, right? So I wouldn't bother with that. So I'm going to take the square root of 29.24, and I'm going to get A is about 5.4. All right, so we found the third side of our triangle. And now if I want to find my angles, I could go and use these, but these are a little complicated. And I could just use law of sines to find the rest. All right, so for angle B, I'll set up sine of 25 over 5.4 equals the sine of b over 9. For angle C, I'll do something, similar. Sine of 25 degrees, degrees there, over 5.4 equals the sine of C over 12. And I'd solve for those, and I'd find each one. And I just remember after you calculate the right side there, so 9 times the sine of 25 divided by 5.4. Okay, you're going to have to take the inverse sine to solve for the angle. So take the inverse sine, and I got angle B to be approximately 44.8. And then actually here with angle C, I don't even need this. That's a lot of work. Not a lot of work, but too much. And I could do angle C is equal to 180 minus 25 plus 44.8, all degrees. And we have angle C is equal to 110.2 degrees. All right, and again, we check the sides and the angles. Shortest angle, shortest side. Longest angle, longest side. And this is in the middle, so everything checks out. All right, any questions there?
No, it's very similar to the law of sines.
Yeah, it is pretty similar. And it's just, you just got to remember which equation you have to use and then just plug in the numbers. All right, let's do one where we have to find an angle. And then that might be it for today. We'll see. We might end a little early. So the one thing that I do want to say, try not to get caught up with how the triangle is drawn. Okay, I've seen it in the past where you have an upside down triangle like this, and people kind of get confused on how to handle it. I see it more with when we're dealing with right triangles and which one is the hypotenuse and what are my other two sides. So if you want to, redraw the triangle, just make sure everything's in the right spot. There's nothing saying that you can't move the triangle around to be more, pleasing, I guess, for lack of a better term. But just make sure all the numbers stay where they're supposed to be relative to your points here, where A, B, and C is. All right, so if you wanted to flip this over, I mean, you could just bring B up to the top, right? And then your 8 would be over here and your 14 would be over there. You can redraw it any way you'd like, but just be careful. All right, so here we're given 3 sides. I have side A is 8, side B is 19, and side C is 14. And I want to solve the triangle. Well, this is literally any of them are up to you. We're looking for all 3 angles. So it doesn't really matter which one we start with. I'm going to start with A just because alphabetical order. So because I'm looking for the angle, I could use my standard form here. But luckily, I gave you guys some alternate forms that help us with that. Right? So I would pick this first one right up here. So I'm just going to rewrite it down here for us. All right, so we have the cosine of A is b squared plus c squared minus a squared all over 2bc. So we just plug everything in. All right, that's our first step. We're going to have 19 squared plus 14 squared minus 8 squared all over 2 times 19 times 14. Now, what's nice about this is the way that this is set up. No matter how, the proportions, you'll always end up with a positive number in the numerator there. Even though we may be subtracting larger numbers. Oh, excuse me. Like if I was looking for cosine of b, I'd be subtracting the square 19 squared, but these two will always add up to be more than that last one. All right, so that's something you don't really have to worry about. So in the numerator, actually I'll put it down here. We have 19 squared plus 14 squared. Oh, I typed the wrong thing, 1 second. 19 squared plus 14 squared minus 8 squared. And I get 493. Down here, I get 2 times 19 times 14. And I get 532, which makes sense. Remember, my next step would be taking the inverse cosine. And I can't take the inverse cosine of a number larger than 1, but this is a fraction. And you know what? You can leave it just like this. So we'll have A is equal to the inverse cosine of 493 over 532. All right, keeping it like a fraction removes that whole part of, rounding to a decimal point. So keeping it as a fraction is a little more accurate. And you could just type it in 493 divided by 532. So the inverse cosine of 493 divided by 532. That's going to get us angle A. That's not my... It is about 22.1 degrees. All right, and that's a pretty small angle, and it's across from the shortest side. So that looks like it should work. And then after that, it's whatever method you'd like to choose, whatever you feel more comfortable with. I can do another law of cosines for angle B, but to save some time, I'm going to do law of sines. All right, so I have the sine of B over 19. And then the other bit of information I have is side A and angle A. So we can plug that in. Oops. That's going to get us angle B is approximately 63.3. And then angle C is the easiest. And we subtract everything from 180. And, uh-oh. Let me double check angle B real quick. Hmm. Where did I mess up? Give me 1 second, I apologize. For some reason, I'm getting angle C to be very large, and that doesn't match with what we have. And I'm trying to figure out. I think I messed up B and C somehow. A is good. Okay, so maybe let's not use the law of sines for B. Let me use another. All right, we'll pick this up tomorrow. We're running a little short on time. So I'd have to do something. I do another law of cosines for side B then. I'm sorry, for angle B then. And we'll hold off on that. Yeah, I'm not sure what happened there. I gotta look into that. Okay, but anyway, you kind of see how we deal with finding an angle, right? And then we find our other angles. All right, so tonight I'm gonna ask you just to solve one like this. I won't give you the angle one since I messed up, and I don't want you to follow my rules if I made a mistake. So we'll revisit the second example tomorrow. All right, guys, have a good day, and I'll see everybody later.